Good morning. Good morning. Hope everyone's doing all right. Give me 1 second to finish getting set up. Got caught by a bridge, so put me behind for a few minutes. Give me a second. All right. So today we're looking at factoring. But did anybody have any questions on anything? Anybody trying to get stuck? Is everybody good? Everybody straight? All right, like everybody's okay. Why is that expired? All right, there we go. So just as a reminder, don't forget at some point you got to get those tests in there. You know, checking with Mr. Davis. And then from there, setting up a time for, to go in there and take a test. So don't want to get too far behind on that. And then of course you got to do all your homeworks. All right. Look at something. Okay. Hmm. Okay, well, we can't not do anything. All right, so just looking at participation in math lab. So as a class, we have a few people that are knocking out their assignments, but as a class, we got to make sure we get on top of this stuff because you don't want to fall too far behind. Because but this class ends at the end of July or beginning of August. It'll be here before you know it if you're not careful. So most definitely make sure you guys, get on this thing. And like I said, start setting up your tests so you can go ahead and knock those out because you can't pass without your tests as well. All right, so had Monday off, so at least have to do something today. So let's look at 13.1 greatest common factor, your GCF. And so when you're talking about multiplying, we are talking about multiplying expressions, polynomials. So if I had x times 2x plus 5. What we did last chapter is that we multiplied this back out. I mean, multiplied that into the parentheses. So x times 2x is 2x squared. X times 5 is 5x. Now, factoring is taking that and reversing the process. It's the reversal of the multiplication process. So you're undoing the multiplication. And so you would take that 2x squared plus 5x and take the x out of each term, and you will have this. All right. And so your GCF, your greatest common factor, would be considered the x. So once again, it's the reversal process of multiplication. Anybody good with that before we scroll up? All right. So let's talk about identifying the GCF, greatest common factor. So if we have the numbers 40, 52, and 32, we want to know what's the greatest common factor. In other words, what's the greatest common number between the three? This factor can divide into each number evenly. So what's the greatest number that can divide into each one of these numbers evenly? So what you want to do is take each number and break it down to prime factorization. So you break them down to prime numbers. You see what I did for 40. So the first thing I did was what two numbers multiply together to give you 40? I did 4 and 10. Can I break down 4? Yes, that'd be 2 times 2. Can I break down 10? That's 2 times 5. So that's the prime factorization, 2 times 2 times 2 times 5. 52, 2 times 26 gives you 52. Can't break down 2, but I can break down 26 into 2 times 3. I mean 2 times 13, excuse me. And then 32, 4 times 8. Then break down the 4 into 2 times 2. Break down the 8 into 2 times 4, but now I can break down the 4 into 2 times 2 as well. So that prime factorization of 32 is 2 times 2 times 2 times 2 times 2. So I'll let you copy that down before we move further. All right, scrolling up some. All right, so now I just listed out each prime factorization. So like I mentioned, 40 is 2 times 2 times 2 times 5. 52 is 2 times 2 times 13. 32 is 2 times 2 times 2 times 2 times 2. So notice over here in the purple, each of what the GCF will be all numbers or variables that each have in common. So if you notice what we have here is 2 times 2 is in common with all three. So it has to be in common with all three. And so that means our GCF would be 4, 2 times 2. So 4 is going to be the largest number that can divide into all three of these numbers evenly. Any questions before we look at the next one? Still some writing. All right, so let's look at another one. This time we have variables involved. 28mn, 24m cubed n. So we take on the same thought process. We break down, use the tree to break down 28 and 24. 28, I did 4 times 7. I cannot break down 7, but I'll break down to 4 into 2 times 2. 24 is 4 times 6, then that's 2 times 2 and 2 times 3. So when I line them up over here, so that's 2 times 2 times 7 times m times n. Don't forget your variables. And then for 24, m cubed n, that's 2 times 2 times 2 times 3. Then I have 3 m's and 1 n. So then you ask yourself, what do you have in common with both terms? So that's 2 and 2, and then we have 1 m and 1 n. So the greatest common factor will be 4 mn. So, of course, if you ever see one that that cause you any issue, make sure you bring it to class so we can talk about it. But that's the foundational process of finding your GCF. You can always break down your number, even if it's an expression form, like you'll see in a second. You can always break down these numbers and terms in this fashion to find the GCF. So we'll look more into that as we progress forward. An expression is prime when it cannot be factored at all. So if you cannot factor anything, it's considered prime. So that is going to be an option. It's going to be rare, but there may be a time when your answer is just prime. And so that will be an option in the math lab when they ask you to factor. Okay, so now here we have an expression. It says factor out the GCF if possible. And this is the expression right here. I wrote some extra notes. Well, I'll just leave it. So we have 12r cubed minus 18r squared minus 30r. And we want to factor out the GCF. So, if we were to go through the tree process that we just finished tackling or using, we would break, 12 into 2 times 6, 18 into 2 times 6, 5 into 2 times 6, break down to 6, 2 times 3, and all stuff like that. Or if you already see it, so for the most part, when you do this, okay, why is my stuff not working? Okay. Most of the time when we do this process is because we're not familiar with the numbers, or if we don't see a GCF. But if you're familiar with all of these numbers, then let me make sure I didn't erase my stuff. Yeah, okay. But when you're familiar with all the numbers, you don't necessarily have to break them all the way down. So I know that 12 is 2 times 6, 18 is 3 times 6, and 30 is 5 times 6. So I know that 6 is in common with all three. So if you're comfortable with the numbers that you're dealing with, you don't necessarily have to break them all the way down to prime numbers. You can just break it down to the numbers that you know that is in common with all of them. And then when I look at my R's, I have 3 R's here, 2 R's here, 1 R here. So the most R's that I can pull out of all three is just 1, because I have 3 in one case, 2 in the other, and then 1 in the other. So my GCF is going to be 6R. All right, so make sure we're okay with that. Questions before we go any further. So now my factorization has to, like I said right here, it has to equal out to what I had originally. I can always check my factorization by multiplying it back out, and it should give me my original expression. So when I take 6r out of this 12r cubed, you have to ask yourself, what is going to be left? Well, we know 6 times 2 is 12, so if I pull a 6 out, 2 will be left. And then if I pull one of the r's out, 2 of your r's will be left. The same thing with 18. Pull 6 out of 18, you're left with 3. And we had r squared, so then you're left with 1r because the other r is out here. And then here for the 30r, if I take the 6 out of 30, we're talking about in reference to multiplication, then I'm left with 5, and then 1r was here, so that r is out front. So when I take this 6r and multiply it to each one of these terms, I'm going to get this original expression. And once again, you can always check that to make sure your factorization is correct. Questions before we go to the next one? All right. So original expression 12a b to the fifth c to the third plus 16 a to the fourth c squared. All right. So you need to pull the GCF out first. And so when I look at 12, that's 4 times 3. 16 is 4 times 4. So 4 is what I have in common with 12 and 16. I have 1a that I can pull out of both. There are no b. I have b to the fifth here, but I have no b here, so I cannot use b as my GCF. And then when it comes to c, I have c cubed and c squared, so I can pull out c squared. I have 3 c's and 2 c's, so the most I can pull out is the lowest number, which is 2 c's. So this is my GCF. And then from there, what's in the parentheses is what's going to be left from each term after you factored out 4ac squared. So taking 4 out of the 12, you left with 3. 4 times 3 is 12. I took the single a, brought it to the front. Couldn't use b, so that's why all of b to the fifth is here. Then I took out 2 c's from that c cubed, so I'm left with 1 c. Then for the second term, 4 times 4 is 16, so I'm left with a 4. Took out one of the a's, so I'm left with 3. And then c squared, all of that is out front, so no c is inside the parentheses for that second term. All right, questions? All right, next one's relatively short, but they want to emphasize factoring out a negative. So if I have negative 5t squared plus 3t plus 4, if you pull a negative to the front, they ask you to factor out -1. That means all of the signs that you originally had will change. So I had -5t squared, so now I have positive 5t squared. I had a positive 3t, so that's minus 3t. And then positive 4 goes to -4. Now, if you were to distribute the negative back, then you get what you originally had. All right. Okay, this one's asking the same thing again. Factor out that negative. We have 7x to the fifth minus 8x cubed plus 3x squared minus 9. If you were to pull negative to the front, that 7x to the fifth goes to negative 7x to the fifth. 8x cubed is now positive. 3x squared is now negative. And then at 9, it's now positive. Just all of these signs change. Mhm. All right, so next one is another factoring out the GCF. So we have 9a to the fourth b minus 18a to the fifth b plus 27a to the sixth b. So when you look at each one of your numbers, 9, 18, and 27, they have 9 in common. 9 is there for the first term. 18 is 9 times 2. 27 is 9 times 3. So we factor out 9. As far as a, we have a to the fourth, a to the fifth, and a to the sixth. So the most we can take out is the smallest number, which is a to the fourth. And then we have a b in each term. So we can pull that out. So notice our GCF is 9a to the fourth b, which is actually that first term. So we got to be careful here because a lot of times people make the mistake when the whole term is the GCF. Make sure you leave a 1 there to represent that place, because when you go to multiply back out, there needs to be something there. So to multiply 2, because this 9a to the fourth b has to multiply to this, and this. But if you don't have the 1 there, then it's only going to multiply to 2 terms. So make sure you're careful. A lot of times people make that mistake and they leave off that term. But whenever your GCF is the whole term, then make sure you leave a 1 there as a part of your factorization. And then for the next one, 2a, 9 times 2 is 18. So you leave it with 2. We took out 4 of the a's, so you left with 1a. And we took the b brought to the front. Then 27 is 9 times 3, so you left with 3. We took out 4 a's, so you left with 2. And then once again, that b is out in the front. All right. 15y cubed plus 20 of y to the fourth. GCF here is 3y cubed. 15 is 3 times 5. 12 is 3 times 4. And we have y cubed and y to the fourth. So the most we can pull out, once again, is the smallest number, which is y cubed. You pull 3y cubed out of the 15y cubed, you're left with 5. Bring it out of the 12y to the fourth, you're left with 4y. All right. Here they ask us to factor out -3. So this time we have to be cognizant of the sign and the factor, GCF that they're asking us to pull out. So we have -3x squared plus 6x minus 33. So we pull -3 out of the -3x squared. You left with just x squared. Pull -3x from 6x. You left with -2x. pull out -3, not -3x, excuse me, -3 out of 6x, you're left with -2x, and then pull -3 out of 11, you're left with positive 11. Questions before we go to the next part? All right. So in black is our original expression that they want us to factor out. So I just want to make sure we're clear on what's going on here. We have 2w times x plus 3 minus 5 times x plus 3. Now what's in common is the x plus 3. All right. So we would treat that the same way we would treat a variable. So if this was written in this way, 2wy minus 5y, and we saw that y was in common, we would just pull the y to the front and you'd be left with 2w minus 5. So the same thought process happens here. It's just that we have an expression that's in common, x plus 3. So you bring the x plus 3 out front and you're left with 2w minus 5. So both of these are the same thought processes. Any questions? Any questions? All right. So here, just reemphasizing the process, we have 6 times x squared plus 4 plus y times x squared plus 4. X squared plus 4 is what's in common with both expressions. So you bring that out front and you're left with what's sitting in front of them, which is 6 plus y. All right. So the last thing in this section is factoring by grouping. And it's going to lean on what we just finished emphasizing those last few examples. So factoring by grouping is something that you will use when you have 4 more terms. So we have 3ax plus 12a plus 2bx plus 8b. And so what we want to do is we want to group together the first two and the second two. So, once you, get used to doing this, some of you may already be used to doing it, you may foresee which terms to factor or group together in the process. But if you don't have any inkling on which way to go, you can never hurt just factoring the first two and the second two together, see if it works out. For most of the problems that you guys come in contact with, they will work out. But there are possibilities where it will not work. You have to rearrange your terms and group together the correct terms in order to factor completely. But you always start off, if you don't have any idea of where to go, you always start off with just grouping together first two and second two, and then go from there. So we have 3ax plus 12a. Now I factor out the GCF from each parentheses. So I can pull 3a out of that 3ax plus 12a. That leaves me with x plus 4 in the parentheses. Then I can pull out 2b from the 2bx plus 8b, and it leaves me with x plus 4 in the parentheses. Now, what's key to this process is that this has to be the same. Whatever's left in the parentheses has to be the same, or you cannot move any further. This goes back to what we were doing last example, where we have what's the same in the parentheses, and we can pull those out front. So that has to be the same when you pull out GCF. If not, then you cannot move any further. So once you're there, you can bring the x plus 4 out to the front, because that's what they have in common. And then you're left with 3a plus 2b in the other parentheses. And that would be a factorization. Over here is just different ways of writing it. Someone was asking me that class, just different ways that it could be done. So as long as 3a plus 2b is in the same parentheses, as long as x plus 4 is in the same parentheses, it can be rewritten a couple of different ways. But but 3a couldn't be coupled with 4, 2x with 2b with the x or anything like that. So questions? Or we do another one. Next one, 16w to the fourth minus 40w to the third or cubed. Then we have minus 12w squared plus 30w. So now here we have to be careful. We want to group together first two and second two, but notice this minus sign is sitting in front of 12. What you do not want to do is separate the minus sign and the 12 from each other. So notice the minus sign is inside the parentheses with the 12. They are attached and they need to stay attached. So a lot of people make the mistake, make sure the minus sign is inside of the parentheses. Then from there, factor out your GCF. In the first parentheses, I'm pulling out 8w cubed. And that'll leave me with 2w minus 5. In the second one, I'm pulling out negative 6w. Don't forget that what's in this parentheses have to be the same as in this parentheses. If I only pull out positive 6, I'll be left with negative 2w plus 5. But I need positive 2w minus 5. So that's why you have to pull out the negative 6. So once again, be careful. Now that we have the same thing in the parentheses, we can factor out 2w minus 5. So it'll be 2w minus 5 times 8w cubed minus 6w. And then you always have to be careful. You always want to analyze your final answer. You always want to make sure that you factor it out completely, because that will be your instructions to factor out completely. And notice in this second set of parentheses here, 8w cubed minus 6w, I actually have a GCF of 2w. You know, if both the numbers are even, you know, nothing else 2 can come out of them. You see the w that's in each term. So that's why I put that statement in red. Always check for GCFs. And as a matter of fact, to make your factoring life easier, factoring out your GCF in the beginning will always be an option for you. We could have taken 2w out of all of these terms in the beginning, you know, if we wanted. But whether you take it out in the beginning or at the end, it doesn't matter as long as you do take it out at some point. So our final factorization will be 2w times 2w minus 5 times 4w squared minus 3. And yeah, always look to factor out the GCF first. That way you don't have to worry about it at the end. All right. Questions, questions, questions. Straight. All right. All right. So not gonna pull up anybody's grade. So so once I start talking about it, I want everybody to think that's what's about to happen. So I wouldn't do anybody like that. But a lot of us are behind on our work. It's not everybody. So if you know you're doing your work, I'm not talking to you. So, but a lot of us are behind on our work. And we got to make sure we stay on top of this stuff. We got to get our homework done, and we have to knock out these tests in order to pass the class. Remember, we're talking about shooting for 75 or better on your assignments. So we are here. Where are we? Oh, 13, right? Yep. So we're right here. That's what we just did today. I'm going to pause right here and give you guys a chance to get closer to being caught up for those who are behind. But we you know, can't, there's not but so many days I could do this, of course, because it's summer. And we got to get these tests in there. So like I said, we need to get with Mr. Davis, especially it'll be hard for us to do it during class if I'm doing days like this, you know, wherein I'm pausing on lecture to give you guys a chance to get caught up. So make sure you guys get with Mr. Davis. It's jldavis@tcc.edu. And like I said, CC me on that and try to set up a time to start getting these tests knocked out. Yeah. So we got what, chapter 13, 14, 17, 18 is on 3 sections, but main chapters 13, 14, and 17. So yeah, we need to get in there and start knocking this stuff out, guys. Any questions on anything before we close out today? Make sure we're okay. Anybody? Next class, we'll pick back up, you know, get started with factoring trinomials. Probably do all 3 of these sections, 12, 3, and 4, because all of them are factoring trinomials. And then go from there. All right. Any questions before we close? Everybody good? Everybody straight? All right. So you guys have a good one. Be safe. Yep, going to the weekend, right? And I'll see you guys on Monday. Take care.